This meeting is being recorded.
In Chapter 3, Problem 4, we're given pairs of compounds, and we're asked to use Table 3.1 to identify the more acidic compound. So Table 3.1 gives us pKa values. So we'll switch back and forth between the pKa table and these compounds to make our determination. So I will give the pKa values for each here. So let's take a look. First we have phenol and water. So let's go to our pKa table here. And you should have followed me. So let's see here. So we have phenol listed here, which has a pK of 9.9. And then we have, where's water right below? 15.7. So let's go record those values. So we have 9.9, and then we have our 15.7 for water. Yeah, we'll write that over here so we don't have to look that up again. So now we're asked to identify the more acidic compound, and we know that the lower the pKa value, the more acidic a compound is because we take the negative log of the Ka to generate pKa. So because of this inverse relationship, the lower value would give us the more acidic compound. So in this case, we have our phenol. Next, if we go to our table and look up this tert butyl alcohol, let's see here. That is, right below again, that's right here, about 18. So this is what we see in the next set. So that is 18. So this is now a higher number, this alcohol, than water. So water would be our more acidic compound. All right, so let's look at the pair of compounds listed with C, and we'll go back to our table. So now we have acetylene and ammonia to look up. So let's take a look. Here's ammonia, 38, and acetylene, 25. So let's go back. So 25 versus 38. So in this case, acetylene more acidic, lower pKa. Next, we have in set D here, we have HCl and hydronium. So we have, let's go up here. So we have HCl is about -7. Hydronium, also pretty acidic, -1.74. So let's put these values here. -7 definitely wins as being more negative. So HCl is much more acidic because of that lower pK value. We already looked up acetylene here, so we know that that's 25. Let's look up ethane here as well. So now instead of an alkyne, we have an alkane. So we go all the way down and we see that this 2-carbon alkane, this ethane, is 50. So now we go back to our comparison here, and now again, acetylene is more acidic by comparison. And then last but not least, we have sulfuric acid, and we have this protonated ketone. So let's look up these two values on our table here. And these are going to be pretty acidic, right? So let's go to the other end. So we have sulfuric acid, the most acidic one listed on this table, -9. And then we have our protonated ketone, which is -7.3. So they're both negative values, but which one is more negative? The sulfuric acid. Because of the lower pKa value, it is a more acidic compound. So we'll continue with the next problem, 3.5, in our next video.